pointers is that there will be few things. Okay, number one, you must understand the concept of pointers. Okay, so this is what I'm going to cover. So hopefully by end of the lecture, you know what is the meaning of pointers. Yeah. How can you declare a pointer? Okay, and then how can you actually initialize pointer? Then maybe pointer arithmetic, and when you want to pass pointer as a argument, right? So these are some of the things: pointer as parameter or argument. Okay, and what else? There's constant pointers and so forth. So those are, and then if let's say we still have time, I'm going to cover dynamic memory allocation. Okay, so things might be hard if let's say you don't pay attention. Okay, so this is something that you need to really pay attention, and if you don't have, I mean, if you don't understand on certain area, you just maybe ask straight away, because based on my discussion with all the students, whenever they came across a pointer as a topic, then they are kind of struggle, okay, to master this pointer. As I mentioned in the lecture, pointers will be used in your data structure algorithm to construct linked lists. Okay, so if you don't really understand on how pointer works, pointer arithmetic, dynamic memory allocation, so on and so forth, then you might be struggling later. All right, so it is not easy if you try to read books, based on my experience, because most of the books, sometimes they describe pointers in different way, different way, in which, in my opinion, is not the best way for beginner to learn pointer. So I'm going to explain pointer in my own way first, all right, as what we have done for other topics. This is to just for you to get some perspective on pointers and how pointers is being used in the program. Then only we go towards whatever that is mentioned in the slides. Okay, I have read the slide, even though this slide is actually coming from the Pearson textbook, but I find that the way the pointer topic is being approached in this textbook is on the difficult side. All right, so yeah, let's dive in. Okay, let's discuss what we have learned so far. Yeah, so you have learned what you mean. What is the meaning of variable, right? So for example, if let's say I want to create variable x, so what happened is that in the memory you are going to have a location, a storage allocated for variable x. Okay, so this is the concept that you already know. If let's say double y, for example, so you're going to have storage allocated for y. Okay, then maybe char z, so you're going to have something allocated. Now, whenever a variable is allocated in the memory, yeah, definitely that variable or that location in the memory should have some kind of what we call as address. Okay, so for example, if let's say I create x, okay, x as a variable, then x will be allocated in the memory, and then maybe the address of that memory is, suppose I put here 1000. Okay, so 1000. All right, now this 1000 is basically the address of memory of x. Now let's say I want to know what is the address of x. Okay, let's say I want to write an instruction C++ so that we can know what is the address of x. So what I can do over here is I can just write, okay, let me just put it here. Okay, so this is my x. Okay, and then if let's say I want to know what is the address of x, I can just write cout the address of x. Okay, and an ampersand symbol over here refer to the address of. Okay, so ampersand means the address of. Okay, so if let's say this ampersand comes together with X, that means I'm saying that I want to know the address of X in memory. So if I run this, I'm going to have is the address of X in the memory. Yeah, okay, that's clear. Now, um, if let's say I assign X is equal to 10, so what you have already know is that if I want to know what is inside X, I can just see out X. And if I want to know the location of X in the memory, so I can just write ampersand X. So if I run this, I'm going to know that, okay, inside X, I'm going to have 10. And X is actually at the location 0 at 7, FF, so on and so forth. Yeah. Okay. Now, what about pointer? Okay. Now, pointer is a variable that can hold address. Okay. X is a variable, but it can hold integer because we already put here integer, right? It can hold values. Okay, normal variable. But the variable that can hold memory address is what we call as pointer. Okay, so that's the concept. Now, if let's say I want to know, I want to create a pointer, right? So to create a pointer is simply um, simply putting star. Okay, so if you declare like this, p is basically a variable that will contain value. But if you want to create a variable that can contain a value also, but however the value is actually memory address, then you can just put star here. Okay, you are telling C++, hey, C++ p is a variable, but p is not going to contain value. It's going to contain memory address. Okay, so if let's say um, I declare p like this, okay, can I? So if I want to assign something, it must be memory address. It cannot be normal value. Okay, maybe I can try like 30. Let's say, okay, it's not supposed to be like this. Let's not try it. Okay, so it should be a memory address. Now, how can you actually assign a memory address? Now, in this case, I can actually assign the address of X. Hi. Somebody asking any question? No? No? Yeah. Okay, so this is the correct way of using P as a pointer. Okay, so then I can just see out P. Okay, just remember, let me just have this. Okay, you have P, then the way you assign memory address is something like this. P is supposed to be uh, having the memory address of X. So, and then when you want to know what is P, so P is actually having memory address. So if I run this, I'm going to get this. Okay, you cannot have X to, I'm not sure, maybe I can just try. So let's say I want to put X as memory address of X, for example. I'm not sure whether this is possible or not. Error. Okay, so this one is error because you cannot use normal variable to contain the memory address. Okay, um, I'm not sure whether is it possible for you to write something like this. Maybe we can try. Okay, this one is also invalid because P is supposed to contain memory address. Okay, so you're going to get error. All right, so that's the first step. You must know a pointer is basically a variable, normal variable. But the main purpose of having a pointer is to hold memory address. Okay. Now, if let's say I have this, okay, let's go back to our. Okay, so let's say we have this. Diagrammatically, what is happening? Okay, this is what I'm going to show to you. Okay, suppose suppose this is the actual address lah, but in this case, I'm just putting 1000 to make it to maintain simplicity. Yeah. So what happened here is for the first line, you have 10. This is going to be 10 because 10 will be inside X. So, and then you create P. Now, diagrammatically, in a diagram, you are basically having another variable, which is P. Okay. Now, P has no, P currently is a pointer because um, we declared as a pointer because there's a star there. Yeah. Okay. Now, whenever we put P equals to the address of X, that means we are having 1000 inside. Okay. 1000 inside. This is the content of P, right? Now, what do you mean by P is having 1000 inside? It means you are pointing to this location. That's why it is called pointer. Pointer will have memory address as the value. Now, the meaning of having memory address as a value means you are pointing to that memory location. Yes. Ya, Mama Khair. Okay, later, Khair. Maybe towards the end. Okay. Um, so that's the concept. Yeah. Okay. So let's go back here. All right. So now you already know how to declare a pointer. You declare like this. This is how to declare a pointer, right? And this is how to assign a memory address to a pointer. Okay, you just use ampersand. Um, and okay, so that means you already know when you see out P, you are going to get memory address. If you see out the memory address of X, you are going to have memory address of X as usual. If you see out X, you are going to have 10. Okay, now my question is, how can I show the content of a variable pointed by P? Okay. Now P is a variable. Yeah, P is currently pointing to this. How can I show the content of variable pointed by P? So the easiest way is I can just put C out because I know P is actually currently pointing to X, right? So if I want to show the content of variable pointed by P, of course I can just simply C out X, right or not? Right? Because currently P is pointing to here. So if I want to know what is the content of the variable pointed by P, then I can just simply C out X, right? Okay. Um, if let's say I don't have X, if let's say I don't want to use X, I want to use P. Okay. So if I write C out P, I'm going to show the memory address. If I want to know what is the content pointed or the content at this location, I can just put here dereferencing operator. Okay. C out star P. So that means I'm going to have 10. Okay. So you might be confused a little bit like here. All right. So the things that you might be confused is because over here you have star. Suddenly here you don't use star. And then here maybe you use star again. Okay. So this is where the student normally get confused. Right. So you must understand what the star means at different contexts. Okay. So number one, if let's say the star is being used during declaration, that means we are saying that, okay, this variable is a pointer, nothing more. The star here just means we are telling C++, okay, the variable is actually a pointer. To indicate this as a pointer, you use star. Okay, that's why it is important for you to know where the star is being used because star has many usage in C++. Star can be multiplication. Star can be indicative of a pointer. Yeah. If let's say star is not being used during declaration, like for example here, it means the content pointed, sorry, the value pointed by pointer P. That's the meaning, all right? So whenever you come across star, check yourself. Ask yourself a question. This star, is it being used in declaration? Oh, okay. If it is being used during declaration, that means this variable is considered pointer. If the star is being used not during declaration, then you know, okay, this is what we call as the value pointed by pointer P. There is a term for this star. It means dereferencing operator. Okay. All right. Similarly, for this one, ampersand also the same. Okay. So if ampersand is being used during declaration, for example, let's say I want to write in ampersand y equals to x, for example. Yeah. This ampersand is being used during declaration. So I'm saying that y is a reference. Okay. But if the ampersand is not being used during declaration, like for example like this, so it means the address of. Okay. So here, if it is not being used during declaration, it means the value pointed by pointer p. Okay. So make sure you know the difference lah. Yeah. Okay. Hopefully, by a little bit introduction on this, you should be able to know some background on pointer, so that when we go further in detail on the slides, you should be always to be able to refer to whatever that I have mentioned earlier. Okay. All right. Let's dive into the slide. So each variable in a program is stored at unique address, as I mentioned. Okay. You have, like for example, here x has its own unique address. We use ampersand to get the address of a variable. Okay. So for example, here, if let's say num is equal to -99, if let's say I want to know what is the address of num, okay, so I can just add the address of. Okay, as I mentioned here, this one means the address of. Yeah. Okay. So it will be address in hexadecimal. Okay, pointer variable. Uh, what is the meaning of pointer variable? Sometimes we call it as pointer. Pointer is actually a variable, okay, normal variable, but specifically the job of a pointer is to hold an address. Okay, as I mentioned here, if you try to assign normal value, you're going to get error, yeah, syntax error. So you must assign address. Okay, so because a pointer variable hold the address, of course, the address of another variable. So we basically says that that pointer points to the data. Okay, so that's why since this is having 1000, so effectively we are saying that P is actually pointing to the location 1000. Yeah, so this is what we meant by that. All right. Okay, this is where I don't really like over here, because straight away it goes to discuss array. Okay, because it will get you confused. But we can skip this first. Okay. I don't want you to get confused with array. Later on, there will be a topic discussing about the relation of pointer with array. So I think we can skip this first. Okay, this one we skip first. Reference variable, also something that you might get confused. So let's skip this first, and also let's skip this. Okay. So pointer variables are another way using memory address work with a piece of data. Okay. Pointers are more low level than array and reference variable. That means you are responsible for finding the address you want to store in the pointer and correctly using it. Okay. Now, these are some of the important skills that you need to know. Number one, how to declare a pointer. Okay. So you declare a pointer by writing the data type of that pointer. If let's say the pointer is pointing to if let's say the pointer is pointing to data value x, so your pointer data type must be also integer. You cannot have this one double, but it is pointing to um, an integer. All right. So otherwise it will be mismatched. So if you want to have a pointer point to an integer, that pointer has to be of the same type. Yeah. Okay. So in this case, int pointer, we just add this in order to declare it as a pointer. So we say that int pointer can hold the address of an integer. Spacing doesn't matter. You can put in the middle, or you can put towards the ints, or you can also put towards the variable itself. So if let's say I want to put it something like this, it is also possible, as long as the star is being put in between the data type and also the variable, it should be okay as well. So you can also put like this. It doesn't mean that integer multiplied by p, because this star is being used during declaration. The moment star is being used during declaration, we know that it is for pointer purpose. Okay, it will not represent multiplication. It will not represent the referencing operator like this. Okay, so just remember. So that's why where you put the star here doesn't matter, because the moment it is inside declaration, so it is considered that we try to declare a pointer. Okay. Once you have declared a pointer like this, of course, you need to assign memory address, because the pointer has to contain memory address. So this is how. The moment you already declare this as a pointer, do not use any star anymore. Okay, just use the name of the pointer, right? Similar like this. The moment I have already mentioned this, okay, as a pointer, then I can just use P as normal. P should contain memory address. Yeah. If I want to know the value pointed by P, then only I add star, right? Okay, so here the moment I have already mentioned, okay, integer pointer is actually a pointer, so I can just assign memory address. How to assign memory address? You can use this ampersand symbol. Yeah. So that in a diagram, for example, this is your in PTR. Okay. It has the memory address of num. This is num. The memory address of num is 0x4A00. So when you assign the memory address to in PTR, so whatever that is inside in PTR is this. So effectively, in PTR is actually pointing to this. Okay, to this location. Now, when you see out in PTR, you are going to get this. But if you want to have 25 as the output, you just see out star in PTR. Eh? Okay, null pointer. Okay, this is new. In C++ version 11, the null PTR keyword, there's a null PTR keyword to represent the zero. This is quite similar to initialize pointer variable to zero. Lah. Okay, so for example, what I'm doing here is I have my P, but my pointer P can currently have some random value. Okay, so if let's say I see out P, see what is the value. Okay, so when I see out P, as you can see over here, the content of P is 0x12000. So this is actually pointing to some location. Yeah. So if we do not want this to happen, we might as well initialize this to zero. Okay, we cannot put like this because oh, somehow can. All right. But the proper way is to put null PTR. Okay. Let's say I remove this back. So I'm going to get some random value like this. I can actually set this to null PTR. So effectively, I'm assigning it to zero. Okay. So by having this, I'm kind of resetting pointer so that it won't point to any random location. Because if we are not careful and forgot to assign some value to P, for example, here, then I might corrupt some other memory location. So it's a good practice whenever we create a pointer, just initialize it to null pointer. Okay. I think previously, see here. No, I think the newest one they put null PTR as the keyword. Okay, so it will initialize pointer to zero. So this is how you can do it. Okay, let's have a look at one example over here. So in x is equal to 25. So we have x. Okay, inside there is 25. And we have PTR. Okay, so this is PTR. Currently pointing to zero. Okay, zero location. This is PTR. Okay, inside is zero. All right, so and then we assign PTR is no longer equal to zero, but PTR is going to have the address of x. So suppose the address of x is 10, or maybe let me just put here 1x lah. Okay, normally address should be more longer. Longer. All right, so what happened here is that I'm going to have 1x. Okay, after this line, and effectively I'm actually pointing to, I'm no longer pointing to zero, but now I'm pointing to here. Okay, then see out the value in x is x. Of course, x is 25, and the address of x is PTR. PTR is 1x in my case, but here it shows 0x7E00. Okay, so this is an example of a program that uses pointer. Okay, moving on. This is dereferencing operator. Okay, star. As I mentioned earlier, this dereferencing operator, if you use it outside declaration, then this refer to different thing compared to if let's say you use it during declaration. Yeah. Okay. So as mentioned over here, it allows you to access the item that is pointing by that pointer. Okay. So if let's say I have here x25, and then I create a pointer. Okay. This means I create a pointer and then I assign the pointer to have the address of x. Then when I see out star in point in PTR, I mean I want to know what is the value pointed by in PTR. Okay. If I remove the star, then I'm having memory address. But if I put star, that means I'm trying to assess what is the value pointed by the pointer. Okay, we call it as indirection operator or maybe dereferencing operator. So both can. So this is an example. Okay, so if let's say we have this, okay, this is x. X will basically display the content of x, which is 25. PTR is pointing to x. So we have this is your x. This is your PTR. And PTR is pointing to x. X is having 25. Okay. See out 25. See out star. PTR means I'm referring to 25. I'm not referring to PTR. Okay. This is important. Definitely there will be question in your midterm on pointers. So star PTR equals to 100. So that means, okay, the moment you have this, what do you mean by this? Okay, I'm not assigning PTR. If I assign PTR equal to 100, I'm going to get um, syntax error because PTR is not supposed to receive any data, but PTR has to receive memory address. Okay. Now, if I put star PTR equals to 100, what happens is that my star PTR means the content pointed by PTR, which is here. So effectively, I'm uh, I'm putting 100 inside here. Okay. So this is what happened here, right? Because of the star. Because if the star is not there, I'm basically put 100 here. Okay, but of course it is not syntactically correct because you cannot assign value in your pointer. Okay, now continue. So once again, here is the value in x. See out x, you are going to have 100 because, okay, initially this is your see out x and then your see out 25. So that's why you have 25, 25 again. And then you have once again, here is the value of x, okay, which is here. And then see out x because it's already converted into 100 here. That means that's why you have 100 here. Okay. And star PTR is also 100. Right? So there are two ways basically. The moment you use pointer, if let's say you want to know what is the content of x, you can simply use x as the normal variable, as what you have learned earlier before in previous topic. But if you, since you have pointer, you might as well use your pointer to actually uh, display the value of x. Okay. By now you might ask why do you need a pointer? Why not just simply use x? Why introduce pointer? So maybe you don't see the value right now, but it is important for you to know how it works. It's quite similar to when you learn maths, yeah. You learn plus, minus, how to do multiplication, how to do division, so on and so forth. But you are not seeing how this is applied, okay, in real problem. But after you have learned so many other domain, now you appreciate why you learn multiplication, why you learn differentiation, why you learn integration. Yeah. Okay. Now I'm just introducing to you how pointer works. Okay. This is the skill that you must understand. You just need to understand how it works. Later on, um, when you learn data structure, when you learn pointer arithmetic, when you learn dynamic memory allocation later, you are going to appreciate why pointer is important. Okay. All right. Okay. Let's learn about the relationship between arrays and pointer. That's why I skipped the earlier slide just now, talking about arrays and pointer because we are going to learn the relationship between arrays and pointer. Okay. Now, before we try to straight away go into the slide, let me explain to you what happened when you create an array. Okay. So when you create an array, for example, maybe array of size, maybe x3. Okay. So you create an array of integer, then the size is 3. So what happened actually? You have this x. Actually, for your array is basically consists of a pointer. this is actually x. Okay, and x is actually pointing to the first location of your array. That's why, let me just show again, duplicate that. Okay, let me just show again this one. Okay, let me just show to you one example. Let's say I have array x of size 3. Okay, and then perhaps I just maybe I initialize it. Let's initialize it to 1, 2, 3, for example. Yeah. Okay. So if I want to know what is the content of first location, okay. So I can just write see out x0. Okay. So what I'm going to have is the value of 1. Okay, the value of 1. Now, what happens if, let's say, I see out x, just x? Because I did mention to you just now, x is actually a pointer pointing to the first location of the array. So, of course, you are going to have uh, memory address here, memory address here, memory address here. Okay. So, if let's say I put x over here because x is a pointer. The concept of array, when I put x, I'm actually creating a pointer that points to a series of location. Okay. But currently x is actually pointing to the first location of the array. So when I run, you're going to get a memory address because x is basically a pointer. Okay. So I don't want to indicate this first when we learn about pointer. I just want to let you know the concept of pointer first. All right. Then only we try to see what is the relation of array and also a pointer. Why do you need to know that this relation is because later on you are going to learn pointer arithmetic, okay, in which it will involve array. So, and this will be, might be also tested in midterm. Okay, so uh, just realizing the fact that array is actually a pointer also in this topic. Don't get confused because you just learned array previously. What's important about array is you need to know how do you declare an array, how do you use an array in for loops, how do you pass your array as an argument, so on and so forth. But under pointer topic, uh, just understand the fact that array is actually also a pointer. Okay, so that explains why when you try to see out x, okay, it will simply show to you the address. Okay, and why if let's say you have another array, for example, 3 like this, you cannot simply do this x. It won't copy whatever content of x inside y. Okay, because once you run this, okay, that you're going to get error because it does not work that way. Okay, your array is basically static pointer. Okay, so that is more complex like static pointer. Then you have pointer that is dynamics. So okay, let's get let let us just stop at this point. So okay, for array and pointer, array name is starting address of array. Okay, what do you mean by that? Okay, it means when you create an array, we are effectively create a pointer. The name of the pointer is vals in this case, and vals is basically pointing to the first location of the array. That's all. Okay, so when you see out vals, you are going to get um, just the memory address because this is the memory address of. Okay, but if you want to know what is the value of what you call the element, the value of the array, you just use subscript. Okay, just use subscript. I'm not sure whether you can actually see out in this case um, star x. You can try. Can. Okay. Star x means what? What do you mean by star? Star means the value pointed by pointer p. Okay. Now, x is actually currently pointing to the first location. the first location. Okay. So this one is actually having this. But star X means the content pointed to by X, which is the first element. So that's why over here you have 1 also. Okay. All right. So if let's say I want to print out number 2 for normal array, I can just put 1, okay, which represent this. Or if let's say um, I want to use X as a pointer, I can just write something like this. If I'm not mistaken, that means my X currently pointing to the first location, but add 1. I mean, move 1 from the current location, and then we are referring to the content, so which is 2. So if I run there, I have it. Okay. So as the array, how do you access the array that you have learned in previous 2 lecture? You can use the subscript. Okay. But now you already know that array is actually a pointer to a series of location. You can also use dereferencing operator in order to access this and this. Okay. So if I want to know what is this, then I can just x plus 2. Okay. So if I run, then I'm going to have 3 here. Okay. Right. Okay. Which is why by now you should be expert in your array. Okay. If you don't know, if you do not know this, I mean, this one is fine also. You just straight away focus on accessing array using index number. Okay. But after you have learned pointer, then you and then the understanding of array is actually a pointer that points to series of location. You can start playing around your code by using the dereferencing operator. Yeah. Okay. So let's go back to here. Okay. So whenever you create an array, it's basically a pointer that points to the first location of the list. You can access, of course, using square bracket with subscript. There's another way, actually, as I mentioned here, by using um, pointer convention. Okay, let's continue. Okay, array name can be used as a pointer constant. Okay, this is what I mentioned just now. Okay, why it is called here pointer constant? Reason why it is called pointer constant, because we cannot change the value of the um, pointer whenever we have created an array. Okay, so for example here, X is pointing to the first location, right? So if let's say I want to have, okay, X, I want to change X to point to some other location, maybe I have here Y, okay, and I want to change, okay, X, don't point to this array anymore, okay, let's point it to Y, for example, right? So if I run, I'm going to get an error because um, this is actually, we call it as pointer constant. That means you cannot change the value, because the moment we change the value, then X will no longer track the array lah, yeah, because we are asking it to change to other things. Even though if Y equals to 3, for example, here, right, the same size, I think we can still cannot.
Can you hear me?
Yes, can.
Hello.
Who's asking? Anyone asking any question? Okay, maybe miscommunication. Okay, let's continue. All right. So if I try to assign something like this, I'm going to also have error because incompatible types lah. Yeah. Okay. So this one is fine because you are going to get 4. Okay. Pointer can be used as an array name. You can have one pointer equals to vals. This is possible because um, this is just a pointer. Okay. So what happened here? What happened here? Let us just try to. So we have 4, we have 7, we have 11. Okay, and this is actually a pointer pointing to the first location. Okay, maybe this one is not maybe I can just put it here, pointing to the first location. Okay, so this is your vals. Okay, maybe this is, I don't know, this is 1000, this is 1001, this is 1002, suppose lah. Yeah. Okay, so let me just put here 1001. Okay, now when you see out the content of location pointed by val, yeah, so you're going to have 4 lah, which is correct. Now what happens if, let's say, I create another one, another pointer, okay, that pointer is actually val PTR, okay, so this is val PTR, okay, and I'm going to have the value of vals. What is the value of vals? 1001. I'm going to assign it to val PTR, so I'm going to have 1001 here. Okay, so what does it mean by this? It means vals now is pointing to 4. But since val PTR is also having 1001, effectively, I'm asking val to also point to the same location. Okay, now 2 pointer is actually pointing to the same location. Vals, this one is, I would say, constant, meaning you cannot change the value here. I cannot change it to 1002 or 103 and so on. This one is not constant. I mean, it's static. This one is dynamic. This one is quite static. Now you cannot change. This one you can change. Okay. And then when I see out val PTR1, val PTR, this is val PTR0, this is val PTR1, this is val PTR2. Okay. So that's why it will display 7 because 1. Okay. So the moment you have a pointer and that pointer is actually stealing the pointer of an array, so you can actually address this pointer using array style. So val PTR0 means this is val PTR0, this is val PTR1. Okay. So yeah, pointer can be used as an array name. This is a pointer. Use it as array name because it is pointing to the same position. Okay. Let's have a look at this example. We have 10, 20, 30, 40, 50. Okay. And see out star numbers, that means we are referring to 10 because numbers is basically a pointer that point to the first location. Okay, that's why you have 10 over here. Okay. More example. We have vals 4711 and then val PTR. Okay, so here we have vals 4711. So this is basically vals pointing to the first location. Okay, suppose this is the first location is, let's say, 1000. Okay, so this is basically having 1000. Okay, all right. Now we have val PTR. So we have val PTR also here. Currently did not points to anything, so just random. Okay, but it is a pointer because we have this. All right, next line. Val PTR equals to val. Okay, val PTR here is going to have the value of vals. The value of vals is 1000, so I'm assigning 1000 to here. Okay, 1000 to val PTR, so I'm having 1000. Okay, effectively, I'm pointing now to here. Okay, same thing. So this one 1000 pointing to here, 1000 here also pointing to here. Okay, now what is val PTR plus 1? Val PTR is 1000. When you plus 1, that means it becomes 1001, right? So 1001 is here. This is 1002. Something like that lah, dia punya the concept. So the adjacent one will be 1001, the adjacent one is 1002. Okay, so it means address in val PTR, yeah, which is 1000 plus 1 multiplied by size of integer. Of course, the actual size, this is I'm assuming that this location is just 1 byte lah. Okay, so 1001 and then second byte 1001, next byte is 1002, so on and so forth. But if it is of size an integer, so it is not 1000 lah. The next one is, because integer is basically 4 byte, right? So this one is supposed to be 100, 0123. So this one is supposed to be 1004 lah, this one. Okay, And then this one is supposed 4, 5, 6, 7. So this is supposed to be 1008. But to make it simple, okay, let's assume that this is just one byte, one byte, one byte, one byte. So this is what it meant by this lah. So when you see out val PTR plus 1, val PTR is 10, plus 1 is 1001. Okay, so we are referring to the next one. But the moment you have star, it means the content pointed by 1001, which is 7. The content by val PTR plus 2 means 1000 plus 2 lah, 1002. So the content at 1002. Okay, here the content at 1001. Okay, so that's why it displays 7, which is here, and this one display 11, which is here. Okay, so you must use the symbol here. So this is similar to what I have, I think I have shown earlier. This one, yeah, same thing. Okay, the moment you use this, that means referring to the content pointed by the pointer. Which location? X. What is X? X is from here. Okay, plus 2, that means here. Okay, so I'm going to get 3 over here. Okay. All right. So next. So array element can be accessed in many ways. The normal one that we have learned earlier or last week is just using script. So vals2 is equal to 11. This is normal way of accessing array. Okay. Vals2 is 7 here. Okay. You can also use pointer to an array, and also subscript. Okay. So this is pointer to an array. Array is already having a pointer lah. But if you can also create another pointer that point to that array and use that pointer in order to access the array, also possible. Okay, so in this case, you can also use, because that pointer is already pointer and array, you can also use square bracket. Same thing, you are going to get same result. If let's say you don't want to use square bracket, also possible, because now you already know that array is actually dealing with pointer. Okay, so you don't want to use this square bracket, you want to use array name and subscript arithmetic. This is later on we are going to learn pointer arithmetic. So vals is basically this one, 1000. Okay, the actual pointer. Plus 2 means this is 1000, plus 2 means 1002 lah. So you are referring to 11. Okay. Plus 2. I think there's something wrong here. This one is supposed to be 2, 0, 1, 2. Okay, we are not referring to this. 17. There must be some other array over here. Okay. So you can just vals plus 2. This is another way. Or you can also have vals PTR plus 2. Okay, same thing. So there are 4 ways for you to access your array element. So vals I is equivalent to vals plus I. No bound checking. Okay. All right. Okay, we try to finish until pointer arithmetic. Let's try to digest whatever you have learned, and then I'm going to cover for another 2 hours the rest. Okay, this is an example. We have double pointer. Okay, definitely this one will point to this because it is type double. Array index is count. Okay, now we have double pointer equals to coins. Okay, so here you have coins. This is the, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the first one is 0.05. Okay, and this is basically coins. Okay, and we have double pointer. So double pointer equals to coin. So we have over here double pointer. Okay, and this is basically pointing to the same location. Okay, and see out double pointer came from 0. So we are using this to basically see out. Okay, so we are going to see out 0.05. So that's why you have here. This is using double pointer. Okay, double pointer punya pointer. And then over here, instead of using double pointer, we use different way. See out coins. Okay, coins is already here. Okay, plus count. So coin plus 0 is 0.05, and then coins plus 1 is actually here. Okay, and then coin plus 2 is here, plus 3 is here, and plus 4 is here. So same thing. It's just different way of doing things. we are going to have the same output. Okay, one is using square bracket, another one is just using arithmetic. Okay, all right. So pointer arithmetic. Um, let's try to cover this. I think we are going to finish until here. Um, until yeah 9:55 lah. Okay, all right. Okay, when we talk about pointer arithmetic, we are talking about adding, increment, decrement. Okay, we have this symbol, right? So this is what we call as pointer arithmetic. So suppose your val is 4, 7, 11, and this is 4, 7, 11. Okay, this is your vals. Vals mean you have here vals. Okay, and you also have val PTR. PTR is here. Which is equals to vals. That means whatever content of vals, let's say 1000, this one is also going to have 1000. So effectively, this is pointing to here, same thing. All right. So when you have val PTR plus plus, that means this one becomes 1001. Okay, for this one. So that's why it says that it point at 7, 7. That means this is 0, 0, this is 0, 0, 0, this is 0, 0, 1, this is 0, 0, 2. So effectively, whenever you have 1, 0, 0, 1, now this is basically pointing to here. Okay. So val PTR minus minus, now it points to go back by one by one location, now pointing to here. Okay, that's why now pointing at 4. So plus equals C out val PTR plus 2. Val PTR is 1. Okay, this one is no longer 1001, but it is 1000. Okay, now 1000 plus 2, it means this is 1000 plus 1 is here, plus 2 is here. Okay, and then star. So that's why you have 11 here. Okay, all right. Next, val PTR. Okay, now here, this is just to see out. That just to see out. When you just see out, it doesn't change the pointer value. It only display what is value at val PTR plus 2, which is 11. Okay, so it's quite different. If you have plus plus, this one you are changing the value, the pointer address. If you have val PTR minus minus, you are also changing the value over here. Okay, but if you just see out val PTR plus 2, that means you are not changing any value. You are just displaying what is the value pointed, value at location val PTR plus 2. Okay, make sure you know the difference. This one will change value of this. This one will change value of this. This one will not change value of this. Okay. Okay, now this one again change value. Val PTR equals to vals. Okay, so we are pointing it to 1000. Okay, which is already pointing in, which is fine. Okay, this one also change the value. Okay, change the value of the pointer variable, because this one equals to val PTR equals to val plus 2, right? So that means this one is going to point to this. Okay, and this is no longer 1000. This is now 1002. Okay, points at 11. See out val PTR minus val. Val PTR is this, okay, which is 1002 minus val. Val is 100. So when you minus these two, you're going to get 2. Difference number of integer between val PTR and 2. So you're going to get 2 for this. Okay. All right. So let's have a look at this example, and then I think we can call it a day. Okay. Just want to make sure that everything is effective. Okay, so you have 1, 2, 3, 4, 5, 6, 7, 8, 8, and then num PTR is equal to set. Okay, so you have your set. Okay, currently pointing to 5, and num PTR is also now pointing to 5. Okay, Then numbers in set are, so count 0, start 6 PTR. 6 PTR currently pointing to 5. So you're going to have 5 over here, start. Okay. And then increase 6 PTR. So 6 PTR now becomes here. And then the next iteration becomes here. Next iteration becomes here. So whenever it updates the position, it will be C out. Okay. So that's why you have 5, 10, 15, 20, 25, 30, 35, 40. Okay. Now the next loop over here. Okay, last position for 6 PTR is here, 40. Okay, after last for loop, it is pointing to 40. So yeah, actually last for loop is pointing to one after, because you count 6 PTR plus and then count slider size. Okay, and then here in this for loop, 6 PTR minus minus. So it is now pointing to 40. Okay, so see out 6 PTR, so that's why you have 40 over here. Next one, you have you reduce again. So now pointing to 35. So that's why you have 35. And then the next one is 30. You have 30. Next one is 25. You have 25, 20, so on and so forth until it reaches 5. Okay. So this is what happening. All right. So I guess we will stop here. If I continue, I'm sure that all of you will be very fatigued. Maybe less efficient. So I'm going to cover for TC1L on Wednesday, the rest of the content, and for TC2L, I'm going to cover it on Friday. Okay, just want to let you know that if you're still um, not aware, this week is basically the Christmas week, whereby all will be handled online. Yeah. Okay, I guess that will be all, unless you have any question to ask.